Hi everyone, welcome to my channel. I'm Minsky and I'm so excited to have you here. If you're learning C programming and you've been struggling with arrays or just want a better understanding of them, you're in the right place. In this video series, we're going to break down arrays step by step so that you can master them before your exams or for your projects. So, arrays are such an important concept in programming because they help us organize and process data efficiently. Whether you're writing a small program or building a complex system, arrays are something you'll use all the time. This is the first part of a three video series. Today, we learn what arrays are, why we need them, and how to declare and initialize one dimensional arrays. Ready? Let's go. So, first of all, let's begin by understanding the basic question: what is an array? An array is a collection of variables in the same data type stored in contiguous memory locations. Instead of creating separate variables for each value, we can store all these values in a single array. This makes our code cleaner and easier to work with. It's like instead of scattering your data, you can arrange them in a continuous in an order so that they're easier to recall and use. Okay, so then think of it like this. Imagine you're running a shop and you want to store the prices of 50 items. Would you create 50 separate variables? Like, let's say, float, price 1, price 2, price 3, price 4, up to price 50. It's not only tedious but also difficult to manage. So, instead we use arrays, like as you can see, if we just give float prices 50, this means that the variable named prices has 50 memory locations that it has allotted to itself, and now we can easily add the values under the same variable named prices, but we just have to make sure of the index. Now I'll tell you what all that is later on in the video. So now it's very easy for us to access the elements, right? In example, the first price will be price 0. That's a special thing in arrays, that indexing or the numbering of objects starts from 0. So this structure makes arrays incredibly powerful for managing data efficiently. Now we understood what is an array and somewhat what the need for arrays is. So the first and foremost concept, like why we need arrays, is that it simplifies data management by grouping related data. Think of arrays like a row of lockers in a school. Each locker has an individual number and you can store one item in each locker. Similarly, an array has a fixed size and each element is stored at a specific index. For example, if we want to store the marks of 100 students in a class, creating 100 variables would be a nightmare, just like the prices example. But with an array, we just simply have to write one line: marks 100. And while using arrays, we write the name of the variable and then we use square brackets. Okay, so the square brackets, when we are declaring it, indicates the size of the array. And when we use the variable, that is marks 4, let's say marks square bracket 4, then this means that this is the mark of the fifth student. Marks square bracket 5 is the marks of the sixth student. So, without arrays, our programs would be much harder to write and maintain, especially when working with large data sets or performing repetitive operations like sorting or searching. So, now, after this, how to refer each element in an array. So earlier I had told a concept of indexing. So we can use index or subscript to identify each element or location in the memory. So if we have an index of j, mj would refer to the jth element in the array of m, which refers to the marks of 30 students in one subject. Like I told you earlier, mj, okay, mj would refer to the j minus 1th element. That's a mistake, I guess, but see, m0 will refer to the first element of the array. So it is very important to note the difference between array size and subscript or index terms. That is, for example, if our array is of the size 30, let's say marks square bracket 30, int marks square bracket 30, then this means that this array will store 30 elements, but the last most element will be indexed, or it will be called marks 29. So by changing the value of j, we can refer to any element in the array. So this has made our process very easy. Now, array has many parts like the indexing, right? And we also told about the memory location. So let's cover them one by one. The first part of an array are its elements. So each item stored in an array is called an element. Example in the array int numbers 5. So this is an array named 5, I mean are named numbers with 5 elements. And this is one way of writing or declaring an array. So arrays, there are two ways to declare arrays. Either the user can input data into the array, or we can declare an array during initialization. That is, we can declare an array right when we are typing the code. So this is right when we are declaring the array, not the programmer, or not the, I mean not the user. So int numbers 5 means it's an array named numbers with 5 elements, and the elements in it are 10, 20, 30, 40, and 50. So next, I had already covered this topic, that is index or subscript. It is the position of an element in the array. Indexing starts from 0 in C. Okay, see, number 0 is the 10th. 10, that is the first element. 10 is called numbers 0, and 50 is called numbers 4. Just like how I had said that if there are 30 elements, the last element will be numbers or marks 29 and not marks 30. Marks 30 is something non-existent in that array, because our indexing starts from 0. Then we have memory locations, continuous allocation. That is, in an array, elements are stored in a contiguous manner. That is, contiguous memory locations. That is, it's in a stretch that we are locating the memory locations. So we have an order, and it is much easier to call back the elements and use them or manipulate them in any way that we want. So this allows for efficient data access and manipulation. So if number 0 is stored at address 1000, the number 1 will be stored at 1004, assuming that each integer will take up 4 bytes of memory space. So it is very easy for, so if our array is an integer array, then even by memory location we can find out what element is it, as it is it the sixth element, is it the seventh element, is it the 100th element, etc. See, numbers 2 will be 1008, and so on. Now, advantages of this contiguous memory, I've been repeating this, but see, first, it's the faster access. We can access elements using the index um, very quickly, because the memory locations are sequential, and it is, we don't have to remember anything. Then ease of iteration. Loops can easily traverse the array because of this continuous memory location. The cursor or the pointer just simply has to keep moving in the same direction for iterating an array. The next one is efficient storage. Arrays make data handling more compact and manageable compared to multiple variables. Okay. Next, we're going to discuss the types of arrays. Now, let's look at the types of arrays we can use in C. The first one is one dimensional arrays. So, one dimensional array is the simplest type of array. It is a single row of data, that is like the marks of students, or consider a student, and we are storing his marks in 5 subjects: subject 1, subject 2, subject 3, subject 4, and his marks, the single student's marks. This is an example of one dimensional array. So it can be a list of names, prizes, or marks. Next one is two dimensional arrays. Two dimensional arrays is more like a table or a grid with rows and columns. Rows and columns is a specialty of two dimensional arrays. One dimensional array, the specialty is that when we're initializing it, we have the variable name, then we have one square bracket, and in it, the number in the square bracket represents the size of the 1D array. That is, it represents how many elements this array can store. In case of 2D arrays, after the variable name, we have two sets of square brackets, in which the first set represents the number of rows and the second set represents the number of columns. Now, 2D arrays, yeah, it's like a matrix. A matrix that we have studied in maths is an example of 2D array. It will have rows and columns. Like example, a chessboard or a timetable. All of these are examples of a 2D array. Next is multidimensional arrays. These kind of extend beyond two dimensions and they're useful for representing complex data, but they're very rarely used in practice. And in this video, we'll focus on one dimensional arrays. We'll explore two dimensional arrays in the next video, so stay tuned. So, this is an animation that I've borrowed from another YouTuber of one dimensional arrays. See, it is just a list, it is a row of data. And this matrix has, I mean, this array has 6 elements, but the indexing starts from 0 and ends at 5. And we're storing each data in each of the memory locations. Next is an example for 2D array. So as you can see, we have the columns and rows. So again, column indexing starts from 0 and row indexing also starts from 0. So the first element, first, I mean top left corner will always be the 0 0 of this array, and the last element is 5 5. However, this element or this array has 6 rows and 6 columns. Now let's move on to how we declare and initialize a one dimensional array. So first, let us understand the syntax. Syntax is basically the data type, array name, and in square brackets we have the size. So data type means an array can only store one type of data. That is, it can store like unlimited number of items, but that those items should be of the same data type. That is, either all of them will be integers, or all of them will be float, or all of them will be characters. Okay. The arrays that store characters are special arrays called strings, which we will be discussing in the third video of the series. Now, so let us have an example. So it can be int numbers square bracket 5. So in this, int is it tells us the data type of the array, numbers is the name of the array, and in square bracket it is 5. So it tells us the size of the array. So this statement declares an array of 5 integers. This will reserve 5 sequential memory locations for storing numbers. Okay. Then initialization of array can be done in two main ways, as I had told you earlier. First one is at the time of declaration. This assigns specific values to each elements in the array. That is, see, int numbers 5, 10, 20, 30, 40, 50. The same example that we had used earlier. Here, the programmer is assigning the values. Now, another method by which we can initialize one dimensional arrays is with the help of the user, as in the user's input can be stored in an array. Let's write a program to take input for an array and display it. Okay. So user input, one main thing is that it uses loops to assign values dynamically. As okay, before I had mentioned a few advantages of the contiguous memory location storage of arrays. So this is where it comes in handy. When the user is inputting data, we can easily use loops so that the user can input the data in that contiguous memory locations. That is, okay, first we the loop might start at I equal to 0, and each time the value of I iterates, so that it is like after I 0 the user will be prompted to put in an input. Then the loop will iterate again with I plus plus, then the user will be prompted to put in I1, similarly, like that, in that way. So the first example is declare a one-dimensional array to store the ages of 5 people and prints the values. So this is the algorithm. So first of all, let us open our file. I mean text editor, and I use gedit because I've downloaded Ubuntu and gedit on my Windows computer. So you can use any text editor that you want. So I'm going to use gedit, and gedit, I'm going to name my file as printage.c. Let's open it. There we go. We have opened our file. Now let us begin. Always we have to start with hash include stdio.h, because we are handling examples that are involving standard input and output. There are many other header files that we can include, but right now we only need this. So hash include stdio.h. We're going to open our main function, which is the one which will be running throughout our program. We have opened it with curly brackets. The first step, declare an integer array of size 5. So they have mentioned the data type. So what is the syntax for arrays? Data type, variable name, open square bracket, size, close square bracket, right? So we're going to declare it here. Int, the name of my array will be age, its size will be 5, and now they've asked us to assign values to the array elements. We can assign it right here itself. So we're going to put, we're going to open a curly bracket. Let's say we are writing the ages of 5 members of a family. So my elements are 39, 32, 15, 10, and 7. Now they've asked us to use a loop to print each value. So when we're using a loop, iteration will occur. So some variable has to iterate every time. So I'm going to declare an integer I to be iterated. Now let me tell you one more thing. Look over here. I've already assigned the values here itself. Now I can also assign values like this. Ages, let's say I've created another variable or array called ages. Fine. Now int ages, and then now I can also do this. I can separately mention each age. That is, see, I mention it as 39. Age is, let's say, age 1 and age 2. Okay. This is age 1, first family, and this is age 2 of the second family. So I'm just showing it because I want to show you how to assign values to the array elements. Okay. Elements. Assign the elements. Okay. Now, int age 1, age 2. Age 2 will be age 2. First element is always 0. Second element is 1. Third, oh my god, age 2. Third element is 2. Fourth element is 3. Fifth element is 4. There is no this. You see this? This is an invalid variable. Why so? Our age to array only has 5 members. So 7, 8, 9, 10, 11. These lines make up the 5 elements. So we have not stated this element. And without stating, we cannot use it. Okay? Look at this. See? Equal to, equal to, equal to, equal to, equal to. Maybe an older family, 42, 40, 21, 19, and 13. And semicolon is a must for any statement. So we have assigned values to the array elements. Now we have to use a loop to print each value, because why do we have to use this? Because use a loop is because arrays, as I've mentioned earlier, it's a contiguous storage of data, right? Continuous storage of data. So with loops, we can easily, like, we don't have to type much. So always, usually we use the for loop. The syntax for loop is for I equal to 0. This is the initialization. I less than 5. This is our condition. And I plus plus, increment or decrement, right? So we're going to increment I every time. We have opened the for loop. So printf age of person percentage or okay, age of person percentage d is equal to percentage d in family 1. So I've used formats like percentage d and percentage d. They are used for integers. So the first percentage d is because I want to print it like this: age of person 1 in family 1. Okay. So for that, I will use I plus 1. This is the variable that will be printed here. Now, why did I use I plus 1? I'll tell it to you. Okay, let's say here I'm using I itself, fine. And the second one will be the element of our first array. So it will be age 1 I. Fine. Now we're going to copy the same loop for the second family, right? It's the same loop. Now paste. Also, we have to add a new line here, okay? Because otherwise then it won't look nice. Maybe a new line here as well. So you have to do that here. Age after percentage d. So age of percentage d in family 2. So here I'm gonna put I plus 1 to show the difference. Here it's age 2. The variable, I mean the array is age 2. So this is it. We have completed the steps mentioned in the algorithm. We have declared an integer array of size 5. We have assigned values to the array elements and we have used the loop to print each value. So, and we have returned 0 because it's the main function has to return an integer, right? That's why we write int main. So we're going to return 0 and we're going to close the bracket, close the function, and we have saved it. Now let us run it. Let's see. The name of our file is printAge.c dot slash output file, and look at this. So family 1, the first 5 are for the family 1s. Okay, here it starts with person 0. Why? Because we used I itself, right? So we don't start counting as 0. And look at this, age of person 4 in family 1 is the last of family 1 because here it's family 2. So the thing is, we have to use I plus 1 always for an aesthetic beauty of our outputs. So age of person 1 in family 2, age of person 2 in family 2, age of person 3 in family 2. Look at this, whatever values we had assigned the arrays, they have been printed here. So I hope this question is clear and now you have an idea of how to declare one dimensional arrays, the two methods by which you can write the data into the arrays, and how we use the loop to print each value in the array. So I hope that question was clear. Now, the second example is to write a program to find the sum of all elements in a one-dimensional array of 10 integers. So here we have to find the sum. So let us look at the algorithm. Here, the first step is to declare an integer array of size 10. And then we're going to initialize the array with 10 values. We're going to use a loop to calculate the sum and then we're going to print the sum. See, after the first question, I'm sure you have somewhat an idea. Now, this question, I hope it will make it much more clear what and how to handle arrays in C program. So, let us open another file, gedit array sum.c. We have opened our file. Just like the previous file, hash include stdio.h int main. Now, the first step of the algorithm, we're going to declare an integer array of size 10. So let us declare integer array int num for the numbers 10. Initialize the array with 10 values. So they have already asked us to initialize the value. So is equal to, let us put 10 random numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are our 10 elements: 22, 36, 58, 12, 11, 9, 36, 75, 91, 63, and 55. Fine. We have declared our array. Now, again, like the last time, always whenever we're working with arrays, we need a loop. So, obviously, I is going to be there. Then we need one more loop. I mean, one more variable. The variable is the sum variable. We need to store the sum of all of these numbers in a variable, right? So, for that, I'm going to use a variable named sum. Okay, and here I'm going to initialize sum as 0. Why? Because otherwise it will start with garbage values. We need it to start from 0 so that 22 is added to 0, so 22. Otherwise, if you do not initialize sum is equal to 0, the sum variable might already have some other garbage value, might be 3000 or something, and it's going to be added to that. Some 22 is going to be added to the garbage value. So in order to avoid that, we're going to initialize sum as 0. Now we're going to open our for loop with for I equal to 0, I less than, here there are 10 elements, so I less than 10 and I plus plus. Then open the for loop. Sum is equal to sum plus num I. Sum plus num, oops, I've written 1, I'm sorry. Sum plus num I, and this is what our loop will be going to do. So what does this loop mean? Let us consider at, okay, I'm just going to type it here. I'll be erasing it soon. When I is equal to 0, okay, num 0, okay, num 0 will be added to what? Sum, right? So when I is equal to 0, Now what is num0? 22. 22 will be added to 0 and this will be stored again as sum. So this is equal to 22. Next case. Now the loop is over. Our loop is going to iterate again with the increment of 0. Increment of I, which is equal to 1. I becomes 1. So num1, see it's num I, right? So num1 will be added to sum. So what will come over there? Let's see. I is equal to 1. Num1. Check num1. This was num0 because it indexing always starts with 0. Now next one is num1, the second element, that is 36. So this is sum is equal to sum plus num I. So what is sum? Right now what is sum? Sum is, see, sum was stored as, see, this is sum. This is the new sum. Sum was 22. 22 and then num I will be added. Num1. Num1 is the second element, that is 36. Okay. And here we will have 58. This will be stored as sum. Did you get me? Similarly, up to I is equal to 9, this loop is going to iterate. Okay. So for this array, the last element will be num9. So I is equal to 9 is the last time the loop will iterate, because when it is I is equal to 10, the condition will be checked. Is I less than 10? Is 10 less than 10? No. It is equal to 10. So the loop will exit. Okay. Loop will be exited. So this is how this loop works. After this, now we have found out the sum. Next step in the algorithm is to print the sum. So printf, now we don't need the loop because we're just going to print a variable sum, right? We're not going to print the array again. Or do you want to print the array? Okay. You know what? We can just print the array also once. For I equal to 0. You know what? You don't have to print the array separately. We can print it here itself, because see, you see the statement? This statement is not something that the user will see, right? This is a backend statement. So here only we can add a printf statement. Printf element percentage d of array equal to percentage d. This one I want it to be like element 1 of array is equal to 22, element 2 of array is equal to 36. So what do I have to do here? Should I put I or I plus 1? Yes, we have to put I plus 1. And after that, this percentage d is basically num I, whatever is being added in the loop. So, and for the aesthetic beauty, we're going to add a new line. All of this is going to become or come in new lines. Then in this printf statement, we're going to printf sum of these elements is equal to, or elements is equal to percentage d comma sum. Now we're going to return 0, close. Before I close this file, let us check for errors. Oops, I found an error. Let me just change the curly bracket. Just change the curly bracket and oops, one more thing, I added an extra element here, so I hope that fixes the problem. Now let us run this program and see. Oh, I just changed the ppt. Anyways, let's run the program. What was the program? Print array sum.c and dot slash output file. Look at this. 22, 36, 58, 12, 11, 9, 36, 75, 91, 63. So these were our elements and it has shown the sum as 413. Now let's take our calculator and check whether this is true or not. So 22 plus 36 plus 58. Oh, sorry. 22 plus 36 plus 58 plus 11, 12 plus 11 plus 9 plus 36 plus 75 plus 91 plus 63 is 413. So our program has worked correctly. It has shown the correct sum, and that's it. So, well, I hope again that question was also clear. We'll be doing more examples in a separate video. Right now, these two are the only basic questions that I'll be doing here. Now, the next part of our thing is how to retrieve these array elements. Okay. So I guess by doing the questions, you already have figured out how to do so. So if we want to retrieve specific element, then we have to specify not only the array or variable name, but also the index number of interest. I'm sure you guys have all understood this point. For example, int array. One more thing. When we are uh, declaring the values of an array during at the time of declaration, that is while we are typing itself, it is not necessary to write a size in the square brackets. It can simply be just square brackets without a number in it. But this is only when we are inputting the values. If the user is inputting the values, then it is necessary to declare or mention the size of the array, because here the computer, while running the program, will realize that there are 5 elements, so it will be storing the values in a contiguous manner. Okay, so see, in this example, int array 13568, we are going to print the second and third element. That is, array 1 refers to the second element and array 2 refers to the third element. So can you guess which two elements will be printed? Yes, you're right. 3 and 5 will be printed because first element is stored as ARR square bracket. Inside the square bracket, there'll be a 0. This memory location, okay, this memory location is assigned this value, I mean, this variable name. And in that variable, we're storing 1. Let us recap. What all did we cover? So in this video, we covered what an array is and its definition, why we need arrays and how they simplify programming, the types of arrays, but mainly focusing on one-dimensional arrays in this video, then how to declare and initialize one-dimensional arrays, both with defined values and user inputs. We also did example program for user input and output. So, arrays are the building blocks for managing large amounts of data and programming, and mastering them will give you a strong foundation for more advanced topics. In the next video, we'll explore operations on arrays, including searching, sorting, and an introduction to 2D arrays. If you've enjoyed this video or found it helpful, don't forget to like, share, and subscribe to my channel. Also, let me know in the comments if you have any questions or specific topics you'd like me to cover. Thanks for watching, and I'll see you in the next video.